All right, we're going to begin reviewing for the Chapter 7 test, but there is one additional topic with volume, or actually one specific type of problem that I need to go over, and this involves volume problems with x is equal to k. So the idea is that we're given a shaded region uh, with a function and between the x values of 0 and k, and we're trying to find out what this the right bound is in this problem. And the way we do that, we're going to set up everything like we do before with area problems. But now the area will be given to us. So now it's asking, given that this is a specific area of a certain value, going through integral process, can you find out the bound, this right bound, x equals k? So the steps that we're going to take, we're going to set up the definite integral equation with k as a bound. In this case, the k will be the right bound or upper bound. And then we're going to use the appropriate integral method for problems to solve this problem and find the bound for k. So let's look at example 1. It says let R be the region bounded by the x-axis, here's the x-axis, by the graph y equals square root of x. Okay, the line x equals k and the line x equals k. And we see that this graph y equals square root of x will go through the origin, and so we know 0 will be the left bound. Okay, so for A, find the line x equals k if the area of the region is 18 square units. So we know this area is 18 square units. We should need to find out what k is. So we're going to set up the problem just like before. So everything will stay the same. Procedure will stay the same. It's just that now we're looking for a different piece of information. So our area formula is the integral from our left bound to our right bound from 0 to k. And with the shaded region, we're going to do top minus bottom because everything's in terms of x. And also, everywhere that we draw a rectangle, we see that the upper rectangle will be hitting the same graph, and the bottom rectangle will be consistently on the bottom on the x-axis. So we do top minus bottom because we're doing it in terms of x, and we have vertical rectangles here. So top graph is root x, bottom graph is 0. So subtract those, top minus bottom, and the 0 just goes away. We're left with square root of x. Now we're told that this area is equal to 18, so we can say that the definite integral from 0 to k of x to the 1/2, I'm changing the root x to x to the 1/2 to get us ready for integration rule, is equal to 18. Okay, so we already know the area. We should have to figure out the bounds. So let's go through the steps necessary for the left side. So to find the integral of x to the 1/2, we go through power rule. So this becomes x to the 3/2 over 3/2, which is essentially flip the 3/2 to be 2/3. So 2/3 x to the 3/2. Evaluate between 0 and k. Okay, we always plug the upper bound in first, so plug k in for x. So we get 2/3 x to the 3/2 minus plug in 0. Now when I plug in 0, that's going to cause this entire expression to go to 0. So then we have f of b minus f of a is equal to, and we know what the area is, which is 18. Okay, so we're essentially solving this equation now. The 0 goes away. We're left with 2/3 k to the 3/2 is equal to 18. Divide both sides by 2/3, which is the same thing as multiplying by 3/2. So 18 times 3/2 reduces to be 27. 18 divided by 2 is 9. 9 times 3 is 27. And now we can just take raise both sides to 2/3 so that we can get k by itself, and also to cancel out this exponent there, to move this exponent to the other side. So raise both sides to the 2/3. The left side will cancel out, leaving us with just k. And then we have 27 raised to the 2/3. Okay, we can think of this as, you can either plug in your calculator or you actually do this in your head as well. You can just cover up the 2, don't worry about the 2. think of this as the cube root of 27 squared. So if you think of this as the cube root of 27 squared, then we can figure this out a lot easier because we don't have to get this to be, we can just figure out, make this a smaller number first and then squaring it. So we know the cube root of 27 is simply 3. And then finally 3 squared will give us 9. So we know our k value is 9. Okay, part B. Find the line x equals k if the volume of the region revolved about the x-axis is 18 pi. So again, we have the same shaded region. We are revolving about the x-axis. So we have a horizontal line. So if it's a horizontal line, our radius has to be vertical. And you see that between the shaded region and the axis of revolution, there is no gap. And because there's no gap, we're going to have a complete solid. So we know this will be using this method. And we're going to be doing top minus bottom. And because it's this method, we only need one radius. So top minus bottom. So the top of the function is top of this radius is on the root x. The bottom of the radius is on the 0. So big R is simply root x minus 0, which is simply root x. And the volume formula for that we're going to be plugging into using this method is pi big R squared between our lower and upper bound is equal to, now we know the area which they tell us is 18 pi. So we essentially just have to go through integral process, evaluate between upper and lower bound, and then solve for k. Okay. We know big R is root x, so plug root x in for big R into the formula pi big R quantity squared between 0 and k. Now the root x and the squared are going to cancel out to simply be x. So we're continuing to solve the left side. Integral of x is simply x squared over 2. Evaluate between our upper and lower bound. Plug k in for x squared. So we're left with k squared over 2 pi minus, now plug 0 in for x, and we're left with minus 0. So we have an equation that we can solve because we know the right side is equal to 18 pi. The pi's can cancel out on both sides. We're left with k squared over 2 equals 18. Multiply both sides by 2. We're left with k squared equals 36. And finally, the square root of 36 will give us 6. Okay, let's look at number 2. Number 2. This is from 1998. FRQ number 1. Let R be the region bounded by the graph y equals square root of x and the line x equals 4. So we essentially have the same graph, but now we're told what the bounds are. Find the area of region R. So to find the area of region R, we do top minus bottom between 0 and 4. And it's the same problem for number 1. It's just that now we know the upper bound, which is 4. So go through power rule. We get x to the 3/2 over 3/2. And plug in 4. Upper bound first, then lower bound. So we get 2/3 times 4 to the 3/2. 4 to the 3/2 is, the square root of 4 is 8, is 2. 2 cubed is 8. 8 times 2 over 3 is simply 16/3. Okay, part B says find the value of h such that the vertical line x equals h divides the region R into 2 regions of equal area. So we know that from part A that the area of this entire region from 0 to 4 is 16/3. So if we split 16/3 into 2 areas of 2 regions of equal area, we're going to have one region being 8/3 and the other region being 8/3. Okay, this will split this area in half because 8/3 plus 8/3 is 16/3. So we can essentially just solve for this problem because it's saying find the value of h such that the vertical line x equals h splits this value, splits the area in half. So if we want to find h, we can just find the definite integral from 0 to h for this region. And we know this region will give us the area of 8/3. So here's our formula. The definite integral from 0 to h of our function, which is root x minus 0, top curve minus bottom curve, I left out the 0, is equal to thirds. So if we know it's equal to 8 thirds, we don't have to worry about the finding area. We just have to focus on finding that upper bound. So root x can be rewritten as x to the 1/2. And x to the 1/2, we can go through power rule, just like from part A, we get 2/3 x to the 3/2. Evaluate between h0 and h. And if we do that, plug in h for x, so we get 2/3 h to the 3/2 minus 0. And we can set this equal to 8 thirds because we know what the area is. So h is the bound that we're looking for. Okay. First thing, move the 2/3 over, divide both sides by 2/3. Same thing as multiplying by 3/2. So the 3's cancel out. We're left with 8 over 2, which is 4. So we're left with h to the 3/2 is equal to 4. Now we can raise both sides to 2/3 to bring that 3/2 over. So we have cube root of 4 squared, which is the same thing as cube root of 16, and not going to come out to be a whole number. You can either leave it like this, or you can use your calculator to to find the approximation decimal value, 2.250. Part C, find the volume of the solid generated when R is revolved about the x-axis. So we have the same shaded region between 0 and 4, and we want to find the volume of the solid. So we can go through, we see that there's no gap between the shaded region and the axis, so we can go through this method. So pi big R squared, which leaves us with pi times x, integral of x. This gives us x squared over 2. Plug in between our upper and lower bound, we get 16 over 2 minus 0, which is 8 pi. So our volume is simply 8 pi cubic units. So we're going to use part C when we move on to the next portion. The vertical line x equals k divides the region R into two regions such that when these two regions are revolved about the x-axis, they generate solids with equal volumes. Find the value of k. So if we know that this entire volume of this revolved region figure is 8 pi, then we can split this in half and say we have one region that'll be a volume of 4 pi and the other region is a volume of 4 pi. So we're trying to find out where can we draw that line, where can we split this solid, where can we split it so that we get equal volumes on both sides. And we know that the entire volume is 8 pi, so one region must be 4 pi and the other region must be 4 pi. So we can simply solve for this problem. Okay, again, this method, big R is root x minus 0, which is root x. So pi big R squared between 0 and k. Now we know that this portion, we're going to set it equal to 4 pi. And then when we solve, we can find k. When we solve for k, we can find where that k value is. So root x squared becomes simply x. Go through power rule, we get x squared over 2. Plug in upper and lower bound, we get plug in k for x, we get pi k squared over 2 minus 0 equals 4 pi. Pi's can cancel out. Multiply both sides by 2. We get k squared equals 8. Take the square root of both sides. Solve for k. So k is root 8, which is not a whole number, but can be reduced to be 2 root 2, or a decimal approximation of 2.828.